All right, question number 12. Anna burned 15 calories per minute running and 10 calories per minute hiking. She spent 60 minutes running and she burned 700 calories. So it just wants us to solve this system. You could do this using elimination by multiplying the second equation by either a negative 10 or a negative 15. That'll make it pretty easy. Or you could use your calculator. So you hit second matrix, go over to edit, hit enter. These have to be in standard form for using the matrix. They are. So 15, 10, and 70 are the coefficients for the first equation, and the coefficients for the second equation are 1, 1, and 60. Then we've got to hit second quit, so that's important. Then second matrix again, over to math and down to B that says RREF, and then click matrix again, hit enter, and the first line there says 1x plus 0y equals 20, or that x is 20 and y is 40. This asks me for x, so the answer would be 20, which would correspond to 20 minutes of running. 20 minutes of running. Okay. Next question. We have a systems of equations. Again, instead of asking me to solve it, ask which statement is true. What is x? So x and y are representing dollars. So if we solved this system, we'd be solving for the prices of daisies and the prices of roses. And you can see these first two questions have to deal with the price. Actually, and so do C and D. C and D also have to deal with the price because they say spent more or spent a certain amount. So we do have to solve this to answer this question. So I'm going to go back to matrix, go over to edit, and I'm going to type this system in here. 5, 4, 32, and then 1, 6, 22, and then second quit. Because I have this as the previous line, I can hit second entry, and it's just going to retype that line for me. So it looks like x is 4 and y is 3, which for this would mean that roses are $4, roses, and daisies are $3. So we got to figure out which one of these is true. A rose costs $1 more than a daisy. And if roses are 4 and daisies are 3, then that is $1 more. So A should be correct. It is good to go ahead and check and make sure these other ones are not correct. It says Samantha spent $4 on daisies each day. Daisies are $3, so that's not true. She spent more on daisies than she did on roses. That's not true because she bought more roses than she did daisies. And also the roses are more expensive. And Samantha spent over 4 times as much on daisies as she did on roses. So she would have spent, we're talking about Samantha. So Samantha is the first purchase. So Samantha is this equation. So she would have spent $20 because you were doing 5 times 4. She would have spent $20 on roses and 12 on daisies. So that's also not true. So A would be your correct answer. Which of the following is the solution? So we have to solve this. We're going to be subtracting 2 from all 3 sides. So subtract 2 from everything. That's going to get me a 3 here. My 2 is now gone, so I have a negative 3y in the middle. And subtracting 2 from 14 would give me 12. My last step is to divide by a negative 3, again, on each side. So 3 divided by negative 3 is negative 1. I divided by a negative, so these signs should flip. And 12 divided by negative 3 is negative 4. So this inequality is actually not over here. But I know my numbers are negative 1 and negative 4. C and D both show positive numbers. And this is just the reverse of what I have. So if I wanted to flip my answer, I can write my negative 4 on this side and my negative 1 on this side. I just have to flip the signs when I flip where the numbers are. So it would be B. B. Y is greater than negative 4, but it's less than negative 1. So it's between the two. Yeah, so this one's actually backwards of that. So it should be B is your correct answer. All right, what do we got here? A baseball team had $1,000 to spend on supplies. They spent $185 on a new bat. New baseballs cost $4 each. This is the inequality. It can be used to determine the number of baseballs that the team can purchase. Which statement about the new baseballs? Which statement about the number of baseballs that can be purchased is true? So we can solve that. So we can subtract the 185 from both sides. So it'd be 1,000 minus 185, and then I'd be dividing that by 4. It looks like. Just 203.75. 203.75. And my B would be on the left, and my sign would still be the same because I did not divide by negative. So baseballs are less than or equal to 203.75. So it says they can purchase 204. Not true, because it's got to be less than 203.75. That is more than. The minimum number of baseballs that can be purchased is 185. That's not true either, because minimum means that's the smallest number that they can purchase, and they could purchase 203 or 202, so that doesn't work either. C, the maximum number of balls that can be purchased is 185. That's not true, because it's higher than that. Actually, I misspoke on the previous one. The minimum number of new baseballs that can be purchased is 185. You can purchase less than that. So they could purchase like 10 if they wanted to, because 10 would satisfy this inequality. C is also wrong, because as the maximum number of balls you can is 185, but we could buy 203, 202, numbers like that. D, the team can purchase 185 new baseballs, but this number is neither a minimum or maximum. That is true. So they could buy more than that or less than that, and that would both be fine. So D is the correct answer there. Mike always leaves a tip between 8% and 20% to the server when he pays for his dinner, and this can be represented by these inequalities below, which is a true statement. When the cost of a dinner, X, is $10, the amount of tip must be between 2 and 8. So we can check that. We can plug a 10 in here. If I plug a 10 in there for X, I get that Y is greater than, and 8% of 10 would be 80 cents. If I plug a 10 in here, 20% of 10 would be $2. So if the meal costs $10, the tip would have to be between 80 cents and $2, not $2 and $8. That's way too much. When the cost of the dinner is $15, and I'm going to need my calculator a little bit. Actually, it should be $1.60, but we'll type it in anyway. 8% times 15 is $1.20. I messed that up. And 20% of 15 is $3. That looks right. So this looks right. $1.20 and $3. When the cost of the tip is $3, the amount of the dinner must be between. So I could go through and prove these wrong, but for the sake of time of this video, we're going to stop there. Tim follows a pattern. Which expression can be used to determine his score after he played video games n times? So what you want to do for these ones is you want to figure out how much this number is changing each time. So if you just use subtraction, so 4,599 minus the previous one, 4,526, it increased by 73. And you just want to check and make sure that it increased by 73 for the next couple ones. So, and it does. So it goes up by 73 each time. So 73 is the rate in which the numbers are changing. That's called your slope. So when you see the number 73 in here, you should be looking for it to be multiplied by n because it's your slope. So this one has it multiplied by the 4,000 number, and same thing with this one. So these are neither of these are right. For part B, if I distributed that 73 in, I would get 73n, so that would work. But the new number that I would get would be enormous. So what is that? 4453 times 73. That number would be 325,000. Okay? And the way you can decipher between which one is the answer, if they both have the correct slope, is to substitute a number in. So this term, this 4,526, that's the first term. This is the second term. This is the third term. This is the fourth term. And this is the fifth term. So if I plug a 1 in for n for the first term, it should tell me that this is the number. If I plug 2 in for n, it should tell me that this is the number. So if I plug a 1 in, A gets me 4,526. If I plug a 1 into B, I get an enormous number in the 300,000s. So A would be the correct answer there. A pizza restaurant charges for pizzas and adds a delivery fee. The cost of dollars to have any number of pizzas delivered is described by this function. Okay, so the 8 is in front of the P, and P was pizzas, or the number of pizzas. So the 8 is representing how much a pizza costs, the dollars. So it's $8 for one pizza, and the plus $3 is your y-intercept. It's your starting amount. It's how much it would cost the customer if they didn't order any pizzas. It would cost $3. So it's probably a delivery fee because it does say that it adds a delivery fee. So the $3 is the delivery fee. So the cost of 8 pizzas is $11. Well, remember, the P in the formula stands for the number of pizzas. So this would be substituting an 8 into P. So I'd be doing 8 times 8 plus 3. That's way more than 11. So A is not correct. B, the cost of 3 pizzas is $14. That's plugging a 3 in for P, which would get me 27, not 14. So that is not correct either. Each pizza costs $8 and the delivery fee is $3. That is the correct answer there. Again, the 8 is in front of the P, which means it's the price per pizza. So C is correct. Which table? Okay, so we're going to go straight to the calculator. When we see a table and we have to make an equation, we're going to go to Stat, click Edit. And we're going to type our table in. You only need to type 2 points in, so I'm only going to type the first 2 in. I can do that because I know this is a linear equation, so I know the first 2 points that I plug in. I know that the rest of them are still going to be in the same line, so I don't need them. So we get those points. Then we can hit, we don't have to hit quit, but you can. You don't have to. Just you need to hit stat calc 4. So our slope is 3.75 and our y-intercept is 2.5. So that looks like B. Jeff's restaurant sells hamburgers. The amount charged for a hamburger is based on the cost of a plain hamburger plus an additional charge per topping, as shown below. So this number that they're asking me about is in front of T, which stands for topping. So it should have something to do with a topping. So it's not B, because B says the cost of a plain hamburger has nothing to do with topping. So it's either the number of toppings, the additional cost of a topping, or the cost of a hamburger with one topping. So again, T stands for the number of toppings. So if I'm looking at question or answer D and it says one topping, that one topping means that T is 1. All right, so if I plug a 1 in there, I still have to pay $5 for the hamburger, and then I have to pay 6 cents for the topping. So that would cost me $5.06. So D is not correct. It's not the cost with one topping. That would be plugging 1 into T. It would not be telling me what that number is worth. And the number of toppings, it's not A either. Why is it not A? Because the number of toppings, it says right here that the additional charge for each topping, T. It tells us that T represents the number of toppings, not the number in front of T. So the number in front of T is the cost of each topping. Let's see. We're only going to do a couple more here. Let's go through this one. A juice machine dispenses the same amount of juice into a cup each time it's used. The equation below describes the relationship between the number of cups into which juice is dispensed and the gallons of juice remaining in the machine. How many gallons of juice are in the machine when it is full? Okay, so X is the number of cups, and Y is the number of gallons remaining in the machine. So if it's full, then that means it has all 180 gallons. So that 180 would be our answer there. John recorded the weight of his dog at different ages, and here's a scatter plot to show that. What is a line of best fit? A line of best fit is a line that goes through these points as best as you can draw it in the middle. We're estimating 18 months. Okay, 18 months is actually only one block off of this graph. So I don't necessarily need to make an equation to answer this question because I'm only estimating just one piece, one block off the side here. And if I follow these points, it's going to be somewhere in this range right here, which if I look across the graph, it's slightly above 30. But but definitely not above 35. So that number would be B, 32. Oh, I'm going to skip over 25 and answer 26 here. It says which value is not in the range. So the range of the function are the y values. Okay. And the y values, the y-axis, that's up and down. So we're thinking about height here. Which number is not shown in the range? So this has an arrow here. I don't know if you can see the arrow. And the arrow means it goes on forever. So everything above here for y, it covers, such as like the number 100 is way up here on the graph. But because there was an arrow here, it means that this graph goes forever. So eventually it will get to the number 100 up there. There's a couple places on here you can see have open dots. So like, for example, this has an open dot, which means that number is not included. That ordered pair is not included in the function. But since we're talking about y, there's a whole line right here. So 4 is actually in the it's in the range because right here's a dot that's at 4 and this whole entire line's at 4. So even though this has an open dot, the function still goes right here. So we still count 4. So 4 is definitely in the range. 5 is right here, and you can see there's a closed dot right there that's on y is 5. So that's definitely in the range. And then we have 0. And 0 for y is right here. And if you go across, there is also a closed dot there where y is 0. So it is B. 3 is not in the domain, or not in the range, sorry, because this is an open dot at 3. And if you look across at y equals 3, there's nothing else there. So that is the correct answer. And I'm going to stop that video here. Thanks for watching.